Good evening, ladies and gentlemen. I warmly welcome you all to the 63rd session of the Intersociety weekly webinar series. So today's topic of discussion is machine learning for IoT devices, and the keynote address will be given by Dr. Reena. Now I warmly invite Ms. Fida Fatima to give the welcome address. Fida?
So a very good day to one and all, and we've all gathered today again for the 63rd talk of the Intersociety weekly webinar series on machine learning for IoT devices by Dr. Reena KE, who is an associate professor at the Department of Electronics and Communication Engineering at LBS College of Engineering, Kasaragod, about machine learning and IoT. Now, machine learning is a branch of artificial intelligence that is influencing the society, industry, and academia in a very large scale. And IoT, which is Internet of Things, is transforming our physical world that we have into a really complex and dynamic system of connected devices on an unprecedented scale as well. And advances in technology are making it possible a very widespread adoption of IoT, which can range from pill-shaped micro cameras that we have that can pinpoint thousands of images within the body, to smart sensors that can access crop conditions on a farm, to the smart home devices that are becoming increasingly popular. So both machine learning and IoT are extremely interesting areas, and the interconnections between both these are really worth for the world to know and spread. Now, so to take us along on today's talk, which is really going to be interesting, we have our speaker for the day, Dr. Reena ma'am. I would like to wholeheartedly welcome you, ma'am, to this session. Once again, she is an associate professor at the Department of Electronics and Communication Engineering at LBS College of Engineering, Kasaragod. I would like to wholeheartedly welcome you, ma'am. I would also like to welcome Professor Rensi Sam Matthew, who is an assistant professor at the Department of Electronics and Communication Engineering at LBS College of Engineering, and also Radhakrishnan sir of Institute of Engineers India, and also our MC for the day and our Zoom facilitator. Our MC for the day is Nesma, and our Zoom facilitator is Amrita. I would like to welcome both of you as well for today's session. So once again, I would like to wholeheartedly welcome all our attendees and all our speakers to today's session. I hope all of you have a great time ahead. Thank you and have a nice day.
Thank you, Fida, for the welcome speech. Now I invite Professor Rensi to give the introduction to the speaker.
I am indeed honored to introduce my colleague and the speaker of the day, Dr. Reena KE. Dr. Reena KE obtained a B.Tech in Electronics and Communication Engineering from Mahatma Gandhi University in 1994 and M.Tech from NIT Calicut in Instrumentation and Control in 2004 and PhD in Electrical Engineering from NIT Calicut in 2018. Her career in LBS started as a lecturer in 1998, and today she holds the post of associate professor. She has several publications to her credit. Her interests include wireless network control systems, wireless communication, machine learning, IoT, and so on and so. She is a life member of ISTE and a member of IEEE. Last year, she conducted an adult FDP in IoT, and this year we are actually hosting 2 FDPs, one in the month of November, one in the next month on LoRaWAN and IoT applications, and another in September on IoT in agriculture. I will be sharing. I can share the links also here. If some of you are interested, you can join that. She was also a faculty for ASAP training in artificial intelligence ML course in our campus too. So indeed, I am proud to introduce the speaker of the day. Thank you, ma'am. Welcome, ma'am.
Thank you, Rensi. Thank you.
Ma'am, you may begin the session.
Okay, thank you. Thank you, Nesma. I thank organizers for providing me such an opportunity to have a talk here in this platform. So we start with the presentation now. We go to the presentation. So today, all of us are enjoying the benefits of IoT and machine learning. So these two areas, how they are helping each other. So that is the focus of the talk today. So I have just organized the talk as some introduction, architecture, and some concepts of machine learning and deep learning, and the recent trends. So the evolution of IoT that actually started in 80s. So some students in Calicut University, they connected a Coca-Cola machine to the internet. That was the first world's first internet connected appliances. That was a Coke machine, and with that, the growing of IoT starts. So now the IoT includes, as the student see, so it covers a lot. It covers a lot of areas. That means it's application you can find anywhere, like agriculture. You can find in building, industrial IoT is there, and wearable devices, smart cities, everywhere. This is this IoT application you can find. So this Internet of Things, we can define it's a connected objects, like things means any device or any, if building, in building automation, we take building as a thing. Okay, a vehicle, this connected vehicles, or this automotive or smart vehicles, etc. Vehicle is coming as a thing, and it has many devices. This IoT, so we generally call it as IoT devices. So we know the sensors is there to catch the different measurements or sensors. Maybe it's light, maybe temperature, or some physical parameters, or that is to be cached using the sensors, like our body sensors. And here different sensors are used, and we have to process the data coming out of the sensors. And so it's if it is a surveillance system, so 24 hours this camera takes pictures, and it has to store somewhere or to analyze, and something of interest we have to find out and give alert, like that. So this is a natural evaluation of technology, that is the link between digital world and the physical world. So this IoT actually, that is very revolution. So industrial, there is a standard is there in this Industry 4.0, and that is a fourth revolution. Industrial revolution is considered this Industrial Internet of Things, IIoT. So there is a prediction that by 2025 there may be 30.9 billion units connected, IoT devices connected to the net. Now it is covering about 20 billion devices. So this is statistics that is published in 2011 by Cisco. Okay, so here this interesting thing is their prediction is by 2020 there may be connected devices will be 50 billion. And the world population, so how this is related. So in 2003, 6.3 billion population was there, and then it is increased like 6.8, 7.2, then 7.6 billion. Whereas the connected devices in 2003, 500 million, then it increased to 12.5 billion. Then it was predicted, this is a statistics in 2011, predicted to 25 billion, but it is less than that. In 2020, it reaches, predicted was 50, but it reaches some 21 billion. We know because of this pandemic and all, there is an sluggishness that was there, or that was not as predicted, but growth is there. We know, all of us know how many interconnected devices we have today, we are using today. So the studies, this graph shows that devices per person is 6.58, or more than 6 devices by 2020. So we all of us using many devices that are the internet connectivity. And one way or another way, we are using the IoT. So in this IoT, we see that there are things involved. Internet connectivity should be the two things, and the communication. Any of this communication, maybe it's low power communication, and then this wide area network for long range communication. So maybe shorter range communication protocols you are using, or for a long range communication you use this mobile services. So with this advent of this introduction of this 5G, there is a large increase in this use of the IoT devices. Maybe the facility may be provided. This enabling technology, one of the main enabling technologies, upcoming technologies, the 5G. Okay, so here short range wireless technologies like Wi-Fi, Bluetooth, and Zigbee are used, and wide range as shown, WiMAX, LoRa. So this LoRa is another promising one. So low power, this that is used, you can use for the wide area WAN, that is wide area network. Similarly, there is another one known as SIGFOX. An interesting communication technology is the narrowband IoT, etc. Then other things we know, all this 3G, 4G, LTE, and 5G. Then IoT in that IoT architecture, it comes the role of big data, because a lot of data we get from these sensors and devices, and we have to store it in cloud for processing and all. Then we need a platform, this IoT platform for the processing and the analysis, etc. Then the protocol should be followed. So this IoT devices continuously collect the data, and this big data generated by these IoT devices normally stored in the cloud. But now the people are now the application, certain application, we need the IoT end devices, or this edge computing or the fog computing, etc. evolves. Because the processing of data, analyzing and processing of the data should be done in real time, and near to that place where you pick the data. And so some application demands that. Then this use of the edge computing or fog computing, etc. we can use. So we are using protocols like MQTT, AMQP, COP, etc. So these are the well-known IoT protocols used. So a simple IoT framework, you can see here, this device is connected using any of the communication techniques to the cloud, and this is connected to any of these apps and third-party services. Very simple. The same this IoT architecture, this is a more detailing one, that is here this different layered, it shows as a layered architecture. So we have studied about the network layers, layered architecture of the computer network. So this IoT mainly consider the three basic layers. One is a perception layer, and top of that the network layer comes, then the application layer comes. So here you can see some starting from this perception layer, sensors are there, different types of sensors depending upon the application you can use. So there are physical objects, and the connectivity is there. So it can be using different techniques, as we see in the previous slide. It can be using a satellite communication or the wireless access point or even wired. Anyway, we should have some internet connectivity, and the network layer, then it is maybe the edge computing you can provide, or fog computing, then or you can have this internet protocol, or you can directly connect to the cloud. So then an analysis can take place. Locally you can do that, or in fog nodes you can do. So big data analytics is taking place, or in cloud it happens. Okay. Then application layer, so it can be used in medical or health devices. A lot of application you can find there. Then building, then smart city, then vehicle. So a lot of application you can find. All this comes in the application layer. And the top layer, that shows some collaborations or business objectives, etc. So, what are the crucial factors behind the rapid IoT expansion? So, there are several factors why the IoT became so popular, or that trend goes increases. So, here the reasons: one is the falling sensor cost. This integrated devices, the cost is becoming less and less because of this large volume production. Technologies cheaper devices you get. Then the falling cost of data collection and storage in cloud or in fog or edge. Then this internet connectivity, it is getting expanded. Then computing power. Okay, so we have GPUs with the popularity, with the use of the GPU. This deep learning becomes so popular by 2015, 14, 15, because of the use of these GPUs. So that is with the computing power, it happened, acting as a crucial factor. Then all of this, that caused a change in the industries. So this industrial people, the mass deployment of IoT devices happened in industries. So this industrial IoT, it happened because they need thousands and 10,000s of devices, sensors, etc. So because of falling the cost of this sensor data storing, etc., there is a flourishing of industrial IoT happened. Then, of course, the pandemic period that also compelled us to use all this, or to explore the facilities of the digital platform. So this increasing, the increasing of the penetration of the smartphone, tablet to laptop, that happened. So here, this is a study done by World Economic Forum. So this IoT growth in post-COVID-19 period, you can see there was a little bit sluggish, but after this, here it grows. Growth is again going up. So this is a study, or this is a study given by World Economic Forum in 2020. So this blue line shows that pre-COVID projection, and this dark blue that shows the post-COVID. So that is increasing than that of the pre-COVID period. The use of the IoT devices, IoT growth. And as you know, a lot of IoT applications and smart home, cities, smart energy, this energy, smart grid, etc. That is very much using this IoT application. Then intelligent transport services, smart healthcare, agriculture, education, industry, government, sport, retail, and IoT infrastructure. That's also very important. Like a huge, like in mines, we can have different sensors deployed, or IoT devices deployed, and get the condition. Otherwise, it is very difficult to once we deploy, or once this commissioning is done in large gas pipes or in mines, etc. Using this IoT, you can monitor the condition of the infrastructure or a bridge, etc. Critical infrastructures you can monitor by the use of this IoT. So now we come to the topic smart IoT system. So all these things contribute to the IoT. So in this smart IoT, you can have a onboard analytics to train and run AI models. So AI, this artificial intelligence, and that is subdomain is a machine learning. So and again the subdomain again under this machine learning, this DL is coming, or deep neural network is coming, deep learning coming. So this is a change of that happened in IoT. So we can build a successful IoT solution that depends on the tens of billions of devices that may be connected to an edge or in home or office, factories, wherever. We can have this smart IoT system if you add this AI models or onboard AI capacity to this IoT system. And this, how we see the IoT devices. So as simple definition, they are hardware things, sensors, actuators, gadgets, appliances, or machines. These sensors will sense the actuators. Actually, we give the control to actuate the things or to take any action, sensing, analyzing, learning, etc. Then we have to do some action. Then that is done by these actuators. Maybe some valve or some alarming system, some alert is given or SMS is sent. Okay. So this IoT devices, they are embedded in a mobile device or industrial equipment and environmental sensors, medical devices, etc. So embedded device, embedded intelligence, this devices is having embedded intelligence also. So this industrial equipment, it is very crucial because predictive maintenance is possible. Once some failure occurs, that may lead to wastage of time and money, etc. But if a predictive maintenance is possible, it would be very beneficial in the industrial sector. So we have to find a balance of this cost and processing power and energy consumption while designing or selecting an IoT device. So you can find a lot of sensors available for different applications. So if you take the case of a mobile phone, you can find at least many of these sensors in a mobile phone. So all these sensors may not be seen in a single mobile phone, but depending upon the different brand or type, you can find there are different in a small device. You are using this at least 10 or 6 or 10 numbers of sensors in a mobile phone itself. So how this IoT devices work, it varies. So IoT devices vary in terms of functionality. So they have some similarities also. So we have sensors to pick up the data. Then there is an integrated CPU or a microcontroller with the network adapter and open source platform, etc. with the. And most cases, IoT devices acquire IP address to this dynamic host configuration protocol. So itself, this IoT device can acquire IP address by itself, or we are using some software. Normally, we use some software to manage the internet connectivity. Some IoT devices are accessible over the public network, like temperature, you're getting the weather information. And this industrial thing, or depending upon the application, some are designed to operate exclusively on private network. So this is an AWS IoT. Amazon Web Service, IoT platform. So device SDK is shown here to authenticate and exchange message, then authentication, authorization, device gateway, that is using the MQTT protocol, device registry, then this API, AWS IoT API, then rules engine, and then device dashboard, that is persistent thing state during intermittent connection. So it is keeping a copy of that, or that backing up. So this AWS services, it provides different services like analysis and other services it can offer. Then this is an example of a Google Cloud platform. So using this wireless connectivity is ESP32 node. Wireless node, you are getting the information and sending the information through this MQTT protocol. Then a cloud IoT core is the Google Cloud. Then this is publishing, subscribing is taking place. That is a communication protocol. Then cloud functions are there. Then BigQuery, storage, etc. is happening. Then we can have an application layer, includes this web app, report, etc. You can have this as the final user interface at the user interface. Then here the question comes, why IoT devices with ML, machine learning? So here in early days, this machine learning is in the cloud platform only, but here there are certain application now demands the processing in the IoT devices itself. So normally the IoT devices are small controller based system with less than 1,000 of the memory of a typical smartphone, that is in kilobyte, whereas other comes in GB and all. So here this processing power is very small in the case of the microcontroller. So network bandwidth and the consumer needs more, or consumer have expectation about using a device. So that is mainly data privacy, security is one thing, and privacy, security, etc. And this demand more on device processing. Here the data is processed on the IoT endpoint, that is edge of the network. Edge computing means that edge of the network you can have some processing also that is given to these IoT devices than cloud-based approaches. So there is no need to send the data to the cloud. So you can preserve your security, can ensure more security and the privacy, etc. So IoT devices that are using AI and machine learning to bring intelligence and autonomy to system and process. So that we can see the application of these IoT devices with the machine learning, autonomous driving, industrial manufacturing, medical equipment, home automation, and everywhere that everywhere it's required. So the terms associated with that, or in order to get the full advantage, you are using, instead of cloud computing, or in addition to the cloud computing, you cannot replace the cloud, but in addition to the cloud computing, edge computing and fog computing, we can have. So some data processing takes place in the IoT devices instead of some centralized cloud computing infrastructure, depending upon the application. So here in edge computing, what happens is this data processing is partially moves to the end network elements, or a new computing model is introduced known as the edge computing. So here this IoT devices, most of the IoT devices are low-end devices. It cannot it cannot handle this complex processes that involves heavy computing. So like GPU, where we need a GPU in order to run a large database, and you are going for a deep learning network, deep neural network, you want to process or the computation is done in GPU in a cloud platform. But that how can we bring that capacity to this end devices? Because these are the devices with very less computational capacity, and memory is also very low. So here, for that, we use this fog node, or the fog computing comes. So an intermediate node between this edge and this cloud is coming as a fog node with sufficient resources. Uh, this fog node is able to handle advanced processing skill tasks and physically located close to the end network elements. So in case of the smart city application, IoT applications in smart city, um, etc., you need your this fog computing, because a lot of thousands of the sensors, they give the data, so we want to analyze this in real time, so without any latency. So one of the main problem with this cloud computing is one is the latency, other is security, etc. So this latency problem you can uh, reduce if you go for a fog computing. So that is a cloud setup, but it is near to that place, like a city. So it is placed near to that. That is why the name it has got fog. And cloud is away, far away, and fog is near to Earth or at this atmosphere. So that is the name it has got. Then what are the communication model using this edge for cloud, etc. So this you can see a communication model, a device to device, a one-to-one communication. You can see a device to device communication using a network. Maybe it's a local LAN, using a LAN, or using a MAN, etc. So using an internet or within the LAN, it can communicate to each other. So a sensor actuator device controller is there, or a sensor bar actuator is there. Like HVAC, this HVAC control, that is a air conditioning of a building. You can sense the temperature, and if it is above a particular one, above the comfort level, you can send the signal. Depending upon the temperature reading, you can adjust automatically the cooling level, etc. That is a very simple application, device to device controller in that locality itself, or in the local network, or using an internet. Here, another one is device to cloud. So device to cloud means here from the device data is feeding to cloud. So any of the cloud service we may take, and here it happens in that mode. So here I already told the problems like the security and this latency, etc. is possibilities are there if you take this device to cloud. Then another one, the third model you can find is device, edge, and cloud. So a device, first it goes to this edge gateway. So local processing is done. This is the end of the network, and it is getting connected to the cloud, that point. So within that gateway itself, the processing can be done. So that is known as the device, edge, then cloud. Okay. So some application needs a fast reaction, like some warning should be given in the case of an industry, some machinery that goes some faults you find, then you have to alert. And in the case of some surveillance, if you see some unauthorized person, you need a fast action. So this camera, this image analysis, video analysis, it will take time, and it needs more bandwidth if you try to send it to the cloud. Okay, so if you use this edge computing in between, that is good. So here you can see a comparison of these three communication model. And this, what is this emojis? It's given excellent, quite good, neutral, depends, very. So this comparison shows depends upon this features, that is ease of deployment. So in device to device, it's very easy, excellent. and device to cloud, it is this neutral, but ease of deployment to this device edge cloud, it is worrying or difficult. And scalability, when you move to the scalability, this device to device very poor, and this device to cloud, it is okay, neutral, and from this device edge and cloud, that configuration is best. Then heterogeneity, different types of the devices or network you can connect. So device to device, it's poor. So like that, you can see this a comparison, and ease of future upgrades, that also good for this device edge cloud configuration. So you can see for this DEC configuration, many parameters like this scalability, heterogeneity, variety in application, etc. They are good, and also future upgrades are good. And this policy consideration, etc., is difficult in the case of cloud and edge. Device to device, it's very easy. And cost also increases if you go for this device edge and cloud. And if you take one example of the smart city challenge in the IoT perspective, you can see here this many vehicles are passing by, so you have to monitor the traffic, and you have to measure the quality of this air. Then there may be some system failures, so maybe gas line is there, laid down, water connection distribution is there, waste management is there, and many infrastructure facilities are there. So you have to have many things to monitor. This is the case of the smart city. So many cities, they are known as smart cities, but could not implement all of the things in one city, but they are adding one by one. So many things are getting added. So here the problem is this tens and thousands of things are connected, so generating heterogeneous data, and this you have to process and monitor many things simultaneously. So if you come to a sensing node architecture, you can find the sensor, for example shown here, the soil moisture sensor is there, then pressure sensor, barometric sensor, humidity sensor, temperature sensor, etc. This is connected to a microcontroller unit. Then a power management unit is there for this microcontroller. Or you can connect to the solar cell also, but solar, that depends upon that application. If you go for some critical infrastructure monitoring like bridges or mines, etc., we cannot bridges, it's okay, or tunnels. What I mean is tunnel or mine, or where the solar energy is not available, you can go for that. So depends upon the application, you can select which one is more feasible. Then you here a communication unit is there, efficient radio communication. So Bluetooth and low energy, this low energy BLE is there, LoRa is there, NB IoT is there, RFID. You can select any of the communication to send the data, or to communicate the data to the platforms. So another very useful application, or this is the industrial IoT. So industrial IoT already we have discussed. So when you introduce this machine learning or the artificial intelligence in this, if advantages are the real-time monitoring is possible, then the control and optimization of processes, resources, and system, predictive maintenance. That is very important. So you can, or if you add this intelligence, artificial intelligence, or the machine learning or deep learning, etc., you are added, then you can increase the productivity, you can reduce the waste, and increased safety is there, reduced cost is there, etc. So this slide shows an architecture of the industrial IoT, and you can see here side by side this industrial Internet of Things market that is increasing. from 2015, 16, 17, 18, you can see a steady growth in the market, industrial Internet of Things market. And here, this architecture, as we see, there are many communication protocols you can use. Then fog computing is used. So industry also, for large industries and all, we need this fog computing. That is an intermediate layer between this IoT devices, this gateway, and this cloud. So final storage will be for a long time, it will be in cloud. So intermediately, you can have this fog computing or fog connectivity. So here, different communication are possible, long range, short range, etc. Or using mobile, this cellular communication is also possible. Then we have this computing. So you can see a local gateway here. This at the edge network is there. Edge device is there at the network that is communicating to this fog network. Then it is fog gateway. You can see it is given to this cloud. So cloud, there are many services offered, and machine learning is for data analysis and study. Then CPS is the cyber physical systems, etc. So what is this machine learning means? We have to perform tasks such as classification, prediction, clustering, etc. And here, this some learning is taking place. There are different kinds in machine learning: supervised, unsupervised, semi-supervised, and reinforcement learning, etc. So there is a learning process that that sample data is given. So it can be labeled one in the case of supervised learning, or it can be unlabeled data in the case of the unsupervised and semi-supervised, a mix of that. And reinforcement learning, a different kind of learning, like some rewards is given to the positive, an action taken, and it is in a positive manner. That means a rewards is given. Some feedback is given, sensing the environment and taking action, monitoring or learning, then taking action, and reward is given. That is the reinforcement. Here you can see the artificial intelligence is a domain, and where you find this, one of the artificial intelligence tool is the machine learning, and deep learning is again a subdomain of this machine learning. And in between this, there's the reinforcement learning is there, that some part of this deep learning, some modules and machine learning. So if you mix this together, you get deep reinforcement learning. So this is a very reinforcement learning application we found in 2017, AlphaGo, Google's AlphaGo, that beaten that chapter, this champion, Go champion. So that was the using the reinforcement learning. So how these things are related, that means here we have sensors, actuators, etc., devices, and that generates or processes the data, and it is given to this big data. So big data can be generated from big data generated from these devices, or sensed by this, all these devices given to this big data that remembers the things. And you can use machine learning or deep learning, where it trains using this data available. It trains the many algorithms, and this suitable algorithm that decides what to be done, and that outcome you can give to this actuator part. So this is a cycle goes in this way. So here the machine learning at the edge device. So that meets the customer demand. So customization is possible, IoT framework development and customization. So depending upon this application or the customer needs, you can customize the IoT framework. So this edge device, edge computing is there, means you can save the bandwidth and latency issues, etc. So here the mix of this machine learning or AI with this IoT, it's very much beneficial. So There are several machine learning algorithms you can find. Commonly used one like linear regression, logistic regression. There are decision trees, support vector machines, and Bayesian models. Like one is a main name base. Then this KNN, K means K nearest neighbor, clustering, random forest. Then there are dimensionality reduction algorithms like PCA or LDA, then gradient boosting algorithms. There are a lot of machine learning algorithms. So uh, we have to check which one is more suitable to our application manually, or nowadays there are auto ML is there. So they identify automatically which algorithm is suitable to particular application. So this is a supervised learning framework. So you have the data collection feature database. So database, we identify some features of the database, which are the important parameters that influence our decision. So from the database, we have to identify the features, prominent features. Then we are preparing analysis, this pre-processing of the data to be done. Then we have to extract the features. Then feature selection is done. Then dimensionality reduction, then modeling. This which model is suitable. We evaluate the model using some performance measures. So this is in the case of the supervised learning, supervised learning algorithm. And says here, this is a general framework, and here you can go for the supervised learning. Means here model is shown as a supervised, training data set is given, and unseen data set testing. Training is done using a training data set. Normally data set randomly it will pick 70% of the data, or a majority of the data for training, and some data is reserved for testing purpose. So 70-30 you can have, or 80-20%, 80% for training and 20% for testing you can have. This data is processed and analyzed, feature extraction, selection, dimensionality reduction, etc. That depends on the application. Then we are testing with machine learning different algorithms for the supervised learning, and we want to analyze the performance measures like error or this coefficient of correlation, etc. is calculated, and best model is selected out of that. So all this in supervised learning, all the data is labeled one, which are the input, which are the output, that labeled data. So unseen data set is also provided for testing, that is also labeled. In the case of this unsupervised model, unlabeled data set is given. This is for clusters. This clustering, we use this unsupervised model, we get several clusters. So no labeled data given. So here also training, testing, etc. is taking place, and here the clusters are formed. So we have the classification, regression, classification, clustering, dimensionality reduction, etc. is possible using this ML algorithms. So regression is actually mainly used for the real-time prediction. And for this discrete time prediction, we use the classification like different classes. If a flower that can be different varieties, same flower, so different classes, or the characters in the character recognition 0 to 9. If you want to identify the digits from 0 to 9, there will be 10 classes starting from 0 to 9. So here this unsupervised model also it is possible. So which pattern, which cluster is having that performance measure, higher performance measure, or lowest error, etc. We will select. Then popular, when you come to this deep learning algorithm, what is the difference between machine learning and deep learning? Here we use deep neural network. So artificial neural network, okay, this is a neuron model. So this is actually mimicking a biological neuron. So we are finding the summation of the input parameters, that is multiplied by weight. So getting the summation as x1w1 plus x2w2 plus xnwn, and a bias term is also given. There is an activation function you can find, and that is the output you are finding as a transformed input, the summation, summed and transformed input. So that is a neuron model, and there is this is in 1950s this neural network model developed. And what is in deep neural network means, in neural network there is an input layer, hidden layer, and output layer, or two hidden layers will be there. In deep neural network, hidden number of hidden layers will be more, so it has a more capacity to learn the things from the data. So in deep neural network, these features are learned by itself. So that is the different comes in machine learning algorithm. We have to specify, or manual handpicked features should be given. Handpicked features should be given. But for this deep learning, it will learn by itself from the image database, or from the database itself. If it will learn about the features, and it will do the classification, or it will give the required result. So there are many popular deep learning algorithms like CNN, RNN, recurrent neural network, long short-term memory, and autoencoders, DBM, DBN, etc. So you can see here an IoT generation at different levels and deep learning models. So here I had real-time analytics, a deep learning model that is in the IoT device itself. Then edge or fog computing, there is a soft real-time analytics, and the deep learning models for big data analytics that is happening in the cloud level, etc. So this is already we have seen. Then this is the DL model. How it is happened means, you can see the training data set x1, x2, x3 is given. Then there are many hidden layers, and data is passing through this hidden layer. So each time, like each one neural network model is multiplied and transformation is taking place. Then we have to minimize the loss function, or the error to be minimized, that is return as a loss function. So this y1, y2, y3, they are the actual outputs, or then predicted one will be y1 dash, y2 dash. So you are minimizing the error between these two actual and the predicted. So a convolutional neural network is more popular, a deep neural network. So from the input layer, you have a convolutional ReLU. This ReLU is the activation function, rectified linear unit. So that is very popularly used than the sigmoid function that we studied in the neural network. So rectify, that is here positive values taken, the maximum of 0 or the given input. So that is taken. So that is the ReLU. ReLU is important. And then some pooling is taking place. And here what happens is, we have a large data set, maybe an image, and we are taking one portion of the image, one kernel or a filtering is done. That is, convolution operation is happening at this layer. And using this activation function ReLU, we are convolving the thing. So a particular region, a filter you can define. Say if your image is of 28 by 28, in the case of the character recognition, we use the image database, that is MNIST database 28 by 28. But you can apply a filter of 3 by 3, small. Then you are convolving the thing. So you get the multiplication of this filter along with this data. Then you are getting the smaller thing here, because this 28 by 28 you are multiplying by 3 by 3 filter, and again you are doing the thing, and the max pooling, maximum value. So if you are getting a matrix, you can take the maximum value within this region. You can take maximum value, that is a max pooling, or the average, that is average pooling. Then again you are doing the convolution over this. So we are getting final details of the image or the input database. In that way, it is identify which features are prominent, which are not, and they are identifying itself by the features and giving the output. So it is fully connected neural network. And you are getting the class. If it is a classification problem, you are getting the output. Here security is also very much important in the case of this IoT. So you can use this MLDL methods for this any security breach is there to identify intrusion detection. You can have intrusion prevention, etc. Also attack detection, attack prediction, or a normal data is there, etc. You can identify using this MLDL model. So this is also very important, IoT security. Then I finished this talk by some recent developments. We will look at some recent developments. So one of the recent development by MIT group, Hans Lab, MCUNet. So this MCUNet, this a microcontroller itself can do this deep learning. So that is very, very important. So this MCUNet already told that this IoT devices, they have very small processing capacity, power and all. So here what they do is in this extensive search for the model, which neural network model is there are libraries and they are searching in NAS mode, they are searching from the library which one is best model, and then they are tuned the deep learning. So many deep learning libraries are there for deep learning, and then they will pick up the deep learning. So in this way, an architecture is proposed, MCUNet, tiny NAS, tiny ML engine, tiny NAS and tiny engine. So this is efficient. So processing power is very low, and they have tested it with TensorFlow. So we know that this Keras, TensorFlow, etc. We need the libraries to do this deep learning. Normally, when we use in this Colab, you can use the Jupyter notebooks to run, or you can use this deep learning, etc. We normally use this GPU using the cloud. So we use it in Colab, Collaboratory offered by Google. It is taking a lot of time, etc. But TensorFlow, TensorFlow libraries are used there. So there is a TensorFlow Lite which is there to install in Raspberry Pi. They have compared this MCUNet performance with the TensorFlow Lite, and quite good. So you can find details when you search MCUNet. That is a recent development. So it is very advantageous. And this is very low power, work with the low power, and time involved is less. And data security you can have, many things you can. That means deep learning you are bringing to a microcontroller, they are telling of about $10. So a microcontroller costing $10 can now do this image processing and all, or video processing. So that is a big step. So we can enjoy this advantage of this. Then another recent trend is self-powered industrial IoT. That means sensors. We know that operated using batteries normally, and this replacing batteries is tedious task. So there are batteries with a solar operated, but that is not possible everywhere. So here, Everactive, a firm Everactive, they are bringing some development without batteries, wireless sensors. Not only this firm, there are many initiatives in this direction. That is sensors, they are generating their own power. So here, if this ever sensors, their sensors, they call ever sensors, they uses low levels of harvested energy from the surrounding environment. So self-sustaining sensors can maximize the return. Okay, so it can reduce the cost because the battery. So there is an interesting map. So we have, suppose you have 1 trillion of IoT devices, and if you consider a battery has got a 10-year lifespan, okay, then you have to change 270 million batteries every day. So then we can have, how much bigger is this battery problem? So if there is some battery-less sensors or devices, it will be very, very beneficial. So green IoT, that may bring to green IoT also. So that is one. Another advantage you can see is as a domain-specific accelerators. That is also that is normally we use GPU, etc. So here, domain-specific accelerator can be used for a dedicated task, range of processing. So there is ASIC is there, but that is for a specific task only. Here in DSA, you can use for a range of application. So you can see here in diagram, this general purpose processing is the domain-specific accelerator is there. So here we can increase the efficiency much higher in the case of this DSA, but the flexibility is less. If you go for general purpose, you can use for any application. But this domain-specific accelerator, especially for this AI accelerator, you can use means it can have the performance or efficiency is getting very higher. So what is the scope of this embedded machine learning for IoT? So it's a prediction that there may be around 175 zettabytes of data generated. So 1 zettabyte means the 10 raised to 21. So if you go for this embedded machine learning for IoT devices, it is bringing very, you can say, large change may occur. You can find a lot of application for that. So with AI powered capabilities, IoT data can be transformed, analyzed, visualized, and embedded across the entire ecosystem. That is in edge devices, in gateways, in data centers, in the fog, or in the cloud. Anywhere you can have this data processing capacity. So that is very, very, very important. Then what are some, we just look on some disadvantages with this. I'll stop. Okay. So there are some disadvantages of IoT like security. So there are some projects that abandoned due to the security issues. Then privacy, the privacy is also to be protected. Then complexity, over reliance on technology, loss of jobs, etc. that are coming as the disadvantage of this IoT. And there comes some key references. And I thank you all. Once again, I thank organizers, and if any queries you can ask. So I will try to answer. Thank you.
Thank you, ma'am. Thank you, ma'am, for that wonderful session. Now, we do have some queries that have come in the chat box. If you have any doubts, please do post your questions in the chat box. So the first question is from Mr. Surendran. He's asking to give an idea about the IoT initiatives in India at present.
So in India, we are using this IoT in agriculture. Many firms are working with this IoT. I don't introduce IoT platform in India, that I am not aware. But many applications and many companies that are using IoT for many of their services in different sectors.
Thank you, ma'am.
Because I am doing, we are post on that note. So we have contacted many firms that are doing this IoT application in agriculture, like hydroponics, aquaponics, etc.
Thank you, ma'am. Mr. N. Ravindranath has also mentioned that it was a very good presentation. And he has also asked a similar question. I believe you've just answered that. Now, yeah, everyone else has thank you for the session since this was really brilliant. Anyone else? Does anyone have any other queries? Okay, I believe that's it. Okay, there's a question from Mr. Nikhil Kamble. He's asking how machine learning can help with energy management systems.
This energy management system, actually, my PhD work that have a case study in CL, Airport Authority, the data. So we can have occupancy related HVAC control. One specific case I studied on that. So here using this occupancy, that is, we know that this airports and like this metro railway station, especially airports, they're very large areas and many unoccupied areas are there, but still HVAC is working with a maximum comfort. So depending upon the occupancy census, we can identify whether it is occupied or not. We can regulate the temperature. So when you connect this to this global warming and all, it is very essential that this energy management, very good scope. This is a need of our to connect this IoT application with the energy management and smart grid also. You can connect the smart meters and you can monitor. You can have different renewable energy sources, etc., that connected to IoT or IoT application. You can have a good energy management also.
Thank you, ma'am, for that answer. Now I'd like to invite Mr. Radhakrishnan from IEI to give the vote of thanks. Sir. Sir, you're muted.
Good evening, ladies and gentlemen. Thank you, ma'am, for a very nice lecture, and you have covered a wide area. Actually, abridged to 45 minutes is a very difficult task because each area itself is a 1 hour talk can be given. Still, you have managed to abridge it to 45 minutes. And how IoT has changed our lifestyle, everything you have covered, and it was very useful talk for our people and especially for the students studying engineering colleges. And definitely, they will be enjoying it. And let me thank you for sparing your valuable time for our evening Wednesday talk. And once again, I thank you, ma'am. Then let me thank our Professor Francis M. Matthew, who has introduced our speaker to the audience for sparing your valuable time, sir. And also let me thank Fida Fatima for giving welcome address and coordinating, Nisma Nias for coordinating and comparing this talk. And out of all these things, let me also thank our Harindra Sir for conducting this 63rd continuous series, 63rd in this weekly seminar series without any break. That itself is how people can understand how difficult it is to get a speaker and arranging all other side work. So let me thank him for his continuous effort, and I also thank all the people who are Intersociety people who have contributed to this webinar series without break. Let me thank once again and all. Thank you.
Thank you, sir. So our next Intersociety webinar series talk, the 64th one, would be on the topic Desired Learning Focus, and it would be the keynote speaker is Dr. K. Savaswamy. He's an advisor at Human Resources at Tata Consultancy Services. So we are looking forward to seeing you all again on next Wednesday. It will be from 6 to 7 as usual on the 30th of June. Thank you. And I'm going to bring the session to a close, handing over to Harindra sir.
Thank you, Mr. Radhakrishnan.
Thank you, sir. Thank you.
Wonderful vote of thanks. And I thank all other volunteers who have contributed to this one, including Francis and Matthew for giving the introducing the speaker, and Professor Reena. You have given a very wonderful talk. In the short time, you have given a lot of information on that. Thank you very much. Look forward for your continued support in the future programs also. I request everyone to attend the next program, the 63rd program, Desired Learning Focus by Dr. Keshavaswamy. He is advisor of the Tata Consultancy Services. Have a great day.
Thank you, sir. Thank you.
Everybody is requested to give their feedback and provide their what are the requirements, if any certificates are required. The feedback, those who are given the feedback will be given the link to the recordings. Okay, Dr. Keshavaswamy.
Namaskar, sir. Thank you.
We will see next week. We will see next week.
Yeah, we will be. it was a great session.
Yeah.
After listening to Dr. Mary, I thought I will give one input for the participants. In April 2018, IEEE Spectrum, if you refer to an interesting article on a Grand Canal from, that is one of the engineering marvel happened in China, linking the rain-rich south to rain-scarred north, that is near Beijing area, about 1400 kilometers man-dug canal. It is operational today, monitored by IoTs. It is a collection of sensors of over 1 lakh sensors of 150 different types of sensors to measure the quantity of water, quality of water, and also structural stability, because that some of those areas are earthquake-prone areas. So measuring stress and other strain, right, and structural damages. About 150 different types of sensors and a very, very massive engineering marvel. The kind of work as an application of IoT on that scale has not been done anywhere else in the world, including America. Possibly that article will be of interest, particularly after listening to a great session by Dr. Mary. Thank you, Dr. Mary.
Okay. Have a great day, everyone. See you next week. Take care. Amrita, you can close the session.
Okay, sir.